In this video, I would like to show the evaluation feature itself. Using the database we already used in the last one. We have already loaded the data. And now we step back into the main window and switch to the evaluation tab. The evaluation tab encompasses everything that we need for the evaluation itself. But of course, the other views will be used. Now, we have several tabs here. The first is the main tab. In the main tab, we select which data we want to evaluate from which sources. So each evaluation works as follows. We select what reference we use and which test data we use. So for example, we have now a reference trajectory data type, the GPS trail data from the simulator, and now we can select which one of the other data sources we want to evaluate. In this demo, we will focus on the multilateration data, and we have one single data source, the MLAT data itself. Now, which data we want to use, we have already defined. Which standard do we want to use? A standard is a collection of requirements in the application. And in this demo, we will use the EUROCAE ED-117A standard, which is, let's say, a surface multilateration standard defined by the EUROCAE, which I will link in the video description. To do that, we select in this drop-down menu the EUROCAE ED-117A standard, and then we can select which sectors we want to use. In this case, we only have this for all sector, and which requirements are mandated within this sector, so should be checked for data that is inside this polygon. In this case, we use the common requirements and the maneuvering area requirements. Now, what do we mean by that? If we look at the data, we see within this yellow polygon the data itself, and then we have to remember that the sector is only defined up to 10,000 feet. So everything that is an overflight is disregarded, and everything that is inside this polygon will be evaluated. Now, what do we mean with these groups here, requirement groups? They are defined within the standard. We can switch to the standard tab. Here we have the currently selected standard. And within the standard, we have requirement groups as defined by the EUROCAE standard and then described by me in this application. And for example, here we have the common requirements, which are probability of identification and false identification requirements, and then area-specific requirements. So in the ED-117A standard, there are different requirements mandated for different operational areas on the surface. Of course, for example, on a runway, the position accuracy has to be better than, for example, in the apron area. The maneuvering area encompasses the runways and the taxiways. Now, here we have the requirements of the probability of target report or probability of detection, the probability of long horizontal gaps, the probability of false target reports, and the reported position accuracy. What these requirements actually mean is too complicated for this short video, so I would rather refer you to the original standard. If you want to look up where this definition comes from, there is a link, basically a textual reference into the standard, so you should be able to find the actual values. Now, in the main tab in the evaluation window, we have now defined which data we want to use as reference, the test data, which standard to use, and which requirements from the test standard to use. As a small note, of course, this is only short representation of how you should actually evaluate the standard. Actually, you should have different sectors for these different groups. but I only wanted to show a simple example. So that's why we're focusing on the simple polygon and only use the moving area requirements. Now, we can click on Load Data. Then we are met with a short warning stating that the evaluation feature is not yet verified and should only be used for testing and validation purposes. You only get this message once. Now the data loading is started. Now we see in the OSG view in the other window the data that will be evaluated. So in red MLAT and in orange the references. Of course, only the data inside the polygon will be evaluated. Everything else is just for additional information. Now, we could click on Evaluate right now. I first want to point out a small detail, mainly the Target tab. So, of course, the application has to know which data belonged to the same target. So in the so-called association task, we create so-called unique target numbers, UTNs. And for example, the target with the UTN 0 has then some data from reference and test, call sign, mode S address, mode A codes, and so on. And we can inspect that by clicking on this target. This then shows all of the data from this single target, which will be used for evaluation. Now, to get a slightly improved graphical representation, we switch the OSG view to a different style. What we do is we switch to the Style tab, we switch the layer mode to UTN DB object data source ID, activate the connection lines, and click on Redraw. This now works as follows. The layers are now start with the UTN and then are split up in the data sources. And also, the target reports are then connected in the order of time of day. This way, we can investigate the different targets that existed, and some of them, since we're using about 18-hour data set, we can, for example, see one target flying from and coming back to the same airport. Another small detail, we can remove the target from the evaluation using this checkbox, and we can add a comment here using a double click, for example, to state why we removed the target, or this should be investigated further, or whatever. Okay, coming back. We now have loaded the data and click on Evaluate. Now, the data that has been loaded is processed and checked, is it, let's say, inside the polygon that we use, the sector, and then for each UTN, for each requirement, a value is calculated and then summed up as a sum for the requirement. After this has been done, the results are presented in the Results tab. On the left-hand side, we have something like a table of contents. On the right-hand side, then the details are shown. So, for example, we inspect in the overview the results by simply clicking it on the left-hand side. Now we are met with a table that shows for each requirement within this sector, how many target reports or update intervals did we have? What is the calculated result? What is the condition that has to be fulfilled according to the selected standard? And did the requirement pass or fail? Since this is simulator generated data, I made sure that everything passes, and I checked also the values that are entered into the simulator, so everything is verified. Now, let's assume this is real data and we want to inspect it. We, for example, now have the reported position accuracy. We can interpret this, of course, from this value and from the requirement in the standard. So in this case, for 95% of the cases, the position accuracy should be better or at least equal than 12 meters. But what if we want to see the details? Well, we can click on the requirement, which will then show in the OSG view, for example, all of the target reports that were outside of this 12-meter threshold. So we see the statistical distribution of the errors. Geographical distribution of the errors. In the histogram view, we see the distribution of all of the distances. In this case, in logarithmic scale, let's disable that. And we can see there is a high peak at about 2 meters, less at 7, a few at 12, and then we have a tail, which we only see when we activate the logarithmic scale. Okay? Now let's say we want to dive further into the result. We double-click on the table row and we step into the section where the details of these requirements are described. At the top, we have some additional details where, for example, we have intermediate values and all of the calculation results in more detail. And at the bottom, we have a list of all of the targets that were evaluated. Each row is a single target. So we see the UTN here. And in this case, they are sorted by the probability of correct position. So the worst ones are at the top. And for example, then we can click on this single row here, and then the respective UTN is loaded. And again, we see where the actual errors, the position distances existed. So let's zoom in a bit. In this case, we have a target report of the multilateration system, which is farther away than 12 meters to the interpolated position on the reference. Now we could, for example, inspect the worst UTNs. And for example, maybe we find out that the errors only existed in a specific area. Or we find out it could be related to the transponder. Or it could be a specific time window where all of the errors occurred. Now, maybe we want to dive deeper to actually investigate each and every one of these offsets. We can again double-click, step again into the subsection. And here we see then for every target report, what is the distance, at what time, and what were the intermediate results that were used then later for calculation. We can again click on each row, and it then steps into the OSG view and highlights this single distance. And so we can inspect where did this occur, are there any irregularities in there that we can maybe document or mitigate in other ways. We can only look at the data here per target report, but we can sort, for example, over the distance. So the worst ones, for example, are about 40 meters off. And then we can have a look why this existed and so on. Now we can step back also. We can use the back button at the top left. We step back into the overview of the requirement where all of the UTNs are listed. And of course, then also step back to the main results. Another interesting point is, let's say we find out that one transponder did produce, let's say, errors which are not of interest in this evaluation, or the reference was too bad to be actually used, then what we can do, we click with the right mouse button on the row and we can click on remove. This then automatically removes this UTN from the evaluation, automatically updates the results that were generated without this UTN, and now we have a slightly improved performance. To step back, also in the targets tab here, we see this target was actually removed. So it's grayed out and the checkbox here is unchecked. And we could add here a comment here stating why we removed it. Okay, back to the results tab, back to the overview. We can investigate all of these issues, and when we are happy with the result and say this is what we expected from this evaluation, from this data, we can of course back up the database and then this result is reproducible, but also we can generate a report. Using the Generate Report button, we can automatically generate a PDF document which gives all of the details that are within the GUI also. So we click on the Generate Report button. We can select a path. We can add an author. We can select which details we want to have included. And then we simply click on the Run button. Now, this generates all of the figures using the actual GUI, saves them as screenshots, and then in this case produces the 62 pages long PDF document. We can use the contents here to again go to the results, and here we have also the same overview tables giving the same figures, and can, for example, then also step in the reported position accuracy using the quick link here. And here we have again the screenshots from the views. Now, of course, this report should not be used to generate all of the figures for all of the targets. This can be a huge report and no one would read that. But as an overview, it's very useful. And also it's very good for, let's say, communication to, for example, other colleagues, and to give them some details about, for example, which targets had what issues at what point in time. This was my small presentation about the evaluation feature of the ED-117A. I would refer you also to the user manual where each of the requirements is discussed in a bit more detail, and also the usage and the current limitations of the approaches used in the applications are discussed. Thank you.